Hello, welcome to Build Coders. I am Sril Pednekar and today we are going to crack a very interesting puzzle known as the Tower of Hanoi. This is a Tower of Hanoi. This looks like a simple game, but it is actually ultimate test to your brain. The goal, you need to move this entire stack from source to destination. And the catch, you can't move two disks at a time, something like this. You just need to move one disk at a time and you can't place a larger disk on the top of smaller disk. This is wrong. Now let's see how can we solve this for two disks. For this, we can put this pink on helper rod, the purple one on destination, and the helper one on the destination. And it's done. We were just able to solve this in 3 steps. Now, let's do a dry run on 3 disk. To do this, we first need to move these two rings to the helper rod and then this ring, the largest, to the destination. Then, this is just same as moving two disks from source to destination. The core logic to solve this question is to move n minus 1 rings, that is 6 rings in this case, from source to helper with help of destination and move finally the largest, that is 7 rings, directly to destination. Next, we have broken this question to a subproblem, that is now our new n is 6 and this is our new helper and this is our new source node. Again, we need to repeat. Now, we need to move n minus 1 rings, that is 5 rings in this case, from source to helper, and the largest, 6th ring, to destination. Again, now our n has become 5, and this is our new source, and this is our new helper. Again, we need to move n minus 1 rings, that is 4 rings, from source to helper, and largest, 5th ring, to destination. Next, we need now n is equal to 4. Again, this is our new source and this is our new helper. We need to move n minus 1 rings 3 to helper with help of destination rod and move largest, that is 4th ring, to destination. Now our n is 3 and this is our new source and this is our new helper. Again, we need to move n minus 1 rings, that is 2 rings, to the helper rod and largest, that is 3rd ring, to the destination. Next, our n has become 2 and this is our new helper rod and this is our new source rod. We need to move n minus 1 ring, that is 1, that is the pink ring, to helper rod and purple one to destination. Next, n is equal to 1. This is our base case. In this is our new source rod and this is our new helper rod. In this case, we need to move the last one, that is when n is equal to 1, directly from source to destination without any need of a helper rod. Now, let's try to code this. Now, let's implement our logic. By now, you must have understood that this is a question of recursion, as we have broken the problem into subproblem and have also identified the base case. So let's begin by writing the function public static void Tower of Hanoi, and this will have 4 parameters. First, the number of disks, that is n in this case, then the 3 rods, source rod, helper rod, and the destination rod. Let's begin with writing the base case, that is when n is equal to 1. In this case, we need to move the disk directly from source to destination. So let's write it. That is, move disk 1 from source to destination. Next, let's break this problem into a subproblem. That is, we need to move n minus 1 rings from source to helper with the help of destination rod. Yes, so now this is our final destination where the n minus 1 rods will go, that is the helper rod. Next, we are left with the largest ring. So we need to move this ring from source to the destination directly. So let's write it. Move disk number, that is n over here, from source to destination. Next, we need to move this n minus 1 disks from helper to the destination via source rod. So let's write it. So move n minus 1 rod from helper rod to the destination rod via source rod. Now let's try with n is equal to 3, and I am naming my source rod as A, helper rod as B, and destination rod at C. Let's see the output. Oh, one important thing. I forgot to write written. That is break from here. Written this. Hence we got this error. Now let's run it. And thus this is our output right over here. Thank you.